Okay, hello everyone. Good evening, good afternoon, morning, wherever you are. Dear authors and invited guests, welcome to Technical Session 2C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress in Information and Communication Technology. This eighth edition is organized in hybrid mode. The physical mode is already ended in the yesterday. It's organized on 20th and 21st February 2023, and the digital mode is today and tomorrow. So, and I hope you all enjoy the knowledgeable and interactive sessions through the day. Just before we get started, there's a special note for the presenters that in this session we have six presentation, and each presentation will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 12 minutes, I will raise a gentle reminder. Okay. And there's one another note for the presenters that you may please all stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. And if you have any query or any update, you can write it to me in the chat box. And just before we get started, I would like to introduce you all to the chairs for this session.
Yes,
We have
good afternoon, everyone. I am Efizal Abdul Qadir from Indonesia, Universitas Islam Indonesia. Today, I will be one of the session chair for this ICICT 2023. Thank you for Sony for inviting me as one of the session chair for this afternoon. Thank you.
Thank you, sir. Thank you. And our next session chair is Dr. Jagdish C. Bansal. I just want to give you some short intro about our session chairs. Just a second. Okay, so about Dr. Abiz Abdul Qadir, he's obtained his PhD in wireless communication from University Technology, Malaysia. He continued his research as postdoctoral fellowship at Big Data Center, Faculty of Computing, UTM. And currently he's working as an associate professor in informatics engineering, Faculty of Engineering, Islamic University of Riau, Indonesia. He is a senior member of IEEE and a member of ACM. His research interests are in software quality, models and architectures, software measurements, information systems, software engineering, machine learning, information security, cybersecurity, and e-systems. And if I talk about Dr. Jagdish Bansal, Dr. Jagdish is an associate professor at South Asian University, New Delhi, and visiting faculty at Maths and Computer Science, Liverpool, Hope University, UK. His primary area of interest is swarm intelligence and nature-inspired optimization techniques. So I welcome you, our both of the session chair for.
Yeah,
Okay.
thank you, Mr. Sony. Yeah.
Okay. So now I would like to start with the papers. Our first presenter is Mohammad Ghanim, and he is presenting on cloud-based simulation model for agriculture big data in the Kingdom of Bahrain. Dear presenter, you may please start your presentation.
Yes, good evening. Can you hear me?
Yes, sir, we can hear you.
Okay, 1 second. The screen is appears to you now, the presentation? You can see it?
Yes, sir, we can see it.
Okay. Good evening, everyone. I am Mohammed Ghanim, a PhD researcher at the University of Bahrain, Kingdom of Bahrain. Today, inshallah, I'm going to talk about one of the first initiatives to digitize the agriculture sector through the creation of a cloud-based simulation model for agriculture big data in Bahrain. طبعا I try to make the presentation concise, as Mr. Soni said, only 12 minutes. So first we will have a small introduction to the data world, then we have a literature review, After that, I'm going to talk about Bahrain and the agriculture in Bahrain. Next, I'm going to preview the objectives of the research, the tools, the methods I used, and technologies adopted for the implementation. And finally, I'm going to have the concluding remarks. Data sources are increasing rapidly, providing different data types and formats. We have now the social applications, the satellite imaging, IoT devices, unmanned aerial vehicles like drones, etc. All of these are generating massive amounts of data in different formats that can be either structured, unstructured, and semi-structured. Moreover, most of the resources are generating real-time data in a very fast pace. On the other hand, the analysis of such data can provide us with insights, knowledge, and it will provide us also a future predictions. This will improve usually the sustainability of our lives. All of that come under the term now big data. From our study, during my study, I figured that researches in big data are roughly divided into analytical and visualization researches, and these are the most dominant researches in the field now. And in sometimes some researches, the authors usually describe a previous stage of the analytics, such as the data transformation or data storage. On the other hand, we have the data engineering researches, where the focus is on the process of extraction, storage, and the processing of data. And actually, they are few comparing to the first one. During my study, I observed that most researchers focused on the adoption of the big data software stack, such as the Hive, Cassandra, Spark, Flum, etc. While few mentioned the implementation on cloud services providers such as Microsoft Azure. In a study that uses a mobile application, GreenLink. This study connected six sensors in a test farm using wireless sensor networks, where the sensors upload the collected data to the cloud for analytics. Kingdom of Bahrain is defined according to the United Nations as a small island developing state, SIDS. This kind of islands usually face unique social, economic, and environmental difficulties. Bahrain is really a small island. However, it's located in the heart of the Arabian Gulf, and with a very strong economic situation and a very resilient ICT position among the MENA countries. However, and for the agriculture sector, I cannot say the same. Actually, agriculture sector in the Bahrain is suffering much. Okay, it has many limitations, starting by limited natural resources such as land and water, till the lack of agriculture data and poor ICT knowledge and adoption. Agricultural data in Bahrain can be roughly distributed in the following sources. These sources are collected based on personal interviews and field visits. We have the main and official source for agricultural data in Bahrain. It's the Ministry of Municipalities Affairs and Agriculture, the Agriculture and Marine Resources Department. This one contains laws, regulations, market data, soil data, water, etc. Also, we have a non-governmental organization called NIAD, the National Initiative for Agricultural Development, and this initiative was established in 2010 to help farmers and vendors to improve the agricultural business here in Bahrain. Also, we have the Bahrain Data Portal, contains some legacy data about the Bahrain weather. And recently, we had the National Space Science Agency in Bahrain here, and it provides some satellite images and studies using the biophysical vegetation indicators. Plus, to that, we have the individual projects by scientists in agriculture field and we other farms. However, almost all of these data have limitations and obstacles to achieve or to reach due to many limitations, including especially the social and technical limitations. My study aims to suggest a national level simulation model based on the cloud for all agriculture stakeholders to connect their data sources securely and privately, also to store their data and to transform the stored data in useful formats. I will focus on identifying data sources, the data ingestion, storage of raw data, and transformation of the raw data. The model will manage 6 data domains: farm, stakeholder, market, weather, crop, and soil. However, in my study, I focused on the weather module for its fundamental impact on Bahrain. The model requires, or the simulation model will require both mobile and web interface. So the author suggests that to develop a progressive web app, PWA, for its features. Both ELT and ETL processes were adapted interchangeably. Data sources and simulated data was identified based on 11 unstructured personal interviews, 5 field visits, and literature and related literature. For ease of use and to avoid the hassle of using different tools, and since Bahrain has very specific agriculture environment in terms of farm size, ICT knowledge, and adoption, the author suggested the use of cloud services provided by Google Cloud Platform. It's flexible, comprehensive cloud services environment, and easy to use. Additionally, a soil sensor and remote sensing account and the device, and also a multispectral camera were adapted to test different data sources and types. Before I start the ingestion, how I collect the data, first of all, I identified the data sources through the personal interviews and field visits. And at the end, I found that we have around 6 categories that share 6 data domains as data owners and users on the same time. For the weather data ingestion, I'm going to use 4 sources of data where adapted: a soil sensor that provides some data about temperature, humidity, and a remote sensing using satellite imaging, crop monitoring technologies. And due to the availability of weather statistical data, weather stations data in a suitable format to be adapted in the application, I simulated it using outside APIs. Also, I downloaded some legacy data from the World Bank as CSV files to simulate the use of legacy data. For the data ingestion, first of all, طبعا I have to, a stakeholder like a farm owner must first register through the PWA. then add farms, crops, and register the sources. For example, a soil sensor must be registered using by the owner. This will trigger the Google Cloud functions, and the cloud functions are used to run the Python scripts, which is the backend in my development. Cloud functions are either triggered directly from the PWA, such in the case of registering data sources, or through Cloud Sub, which is a messaging system, stands for publishing subscription. Or it can be triggered by a cloud scheduler, which is a cron job. Raw data are either loaded in a structured format into Cloud SQL, MySQL directly, or into the cloud storage in raw format like CSV, JSON file, or even images. And at the end, a transaction table is responsible to manage all metadata stored. These metadata stored in the transaction table will use to transform the data and extract the required data. For example, in the weather, we are going to extract, for example, temperature, humidity, transform these data, aggregate, clean, and all these transformed data will be stored in a warehouse on Google Cloud platform called Google BigQuery. It's a very strong tool that can be used for fast analytical and visualization processes. Finally, as a conclusion, this study is a part of a project aims to improve the agriculture sustainability in Bahrain. It is this research paper is the second phase in the project, and it's based on a conceptual framework called Agro Bahrain. The study targets mainly to establish a national agricultural big data repository where different agricultural applications can be implemented to improve production and mitigate resources consumption, such as smart irrigation systems, plant diseases detection, etc. That's it, and thank you for listening.
Okay, thank you, dear presenter. Dr. Kadi, do you have any question with the presenter?
Yes, thank you, Mr. Soni. Okay,
Yes.
thank you, Mr. Muhammad Garim, for the presentation. So, do you specify for the, I mean, what kind of the agriculture you take care in this big data collection? The first, are you specified to the like a fruits or other rice field or other species to the one of the field or just common? And how long you collect data? I mean, is it 1 year, 2 years? So how the weather situation, as you mentioned, the temperature, the humidity, how impact to the agriculture? Is it very much impact? And the third one, do you apply some sensing or just collect data for the secondary data from the other third-party data?
Thank you, Doctor, very much. Actually, very nice questions. Regarding the first point, طبعا Bahrain has the major agriculture or the major crop in Bahrain is date palms. We have date palms.
Oh, date. I understand. All right. Yeah.
And we have some vegetables. We have some fruits. We are trying to improve this kind of production. Actually, as I show you before here in this one, as you can see that we are heavily dependent on imported crops. Almost around 20% of the production on vegetables and 4%. The remaining we are heavily dependent on imported crops. So this project is one of the projects that we are helping to improve the production for it. For the data, yes, I used mixture, both secondary data and I'm using sensors data. I already have soil sensors from Techno company. Okay, it sends data through 4G connection to our website as a JSON format, and then I receive it. Also, I have subscription to satellite sensing, the EOS, the Earth Observation System, crop monitoring application. Also, it can generates images and it generates some data like the vegetation index and so on. However, the target of this project is not to collect data, but to initiate the collection of the data, because we already don't have data in Bahrain. So this is a framework to process how to collect the data, then we show how we can transform it, then how we can store it using the cloud.
Thank you. I mean, like now I am in the tropical region because the temperature is not much different. So like other countries like Europe, they have position. So we need to manipulate the weather to the certain condition like temperature. Then I just to know how the Bahrain situation is. It very much deviation from the lowest temperature and the highest.
Yeah. Bahrain is very humid, very high temperature most of the year, which is making usage of natural resources like water we have very much. So we consume a lot of water for irrigation. Due to this kind of conditions.
Thank you. Thank you, Mr. Sonny.
Thank you very much.
Okay, so I just want to invite our next presenter. Just a second. Goodal Atek, and he is presenting on development of a web-based strategic management expert system using knowledge graphs. Dear presenter, you may please start your presentation.
Hello. Yes, I'm ready to share my screen. Now I will start sharing my screen.
Yes, please, sir.
Can you see my screen now?
Yes, sir, we can see your screen.
Okay, and you can see the presentation as well, yes?
Yes, sir.
All right, so I will start, and I have, I think, maximum 12 minutes. Is that right?
Yes, sir.
All right. Everybody, welcome to today's presentation, and thank you, the chairs of the session, and the moderator for helping us in today's session. All right. So our work is development of a web-based strategic management expert system using knowledge graphs. Basically, we developed an expert system about strategic management, and for this one, we used knowledge graphs. This is a work with 6 co-authors. We spent so much time for this research over so many years, and finally it's time to wrap it up and present it as a research. So basically what we did here is we developed a system called Strategy Advisor. So it's a software, but then there's a strong methodology behind it. And that multi-stage methodology is also something unique that we haven't seen in the literature. It consists of an analysis of agent roles and stages, identification of the grammars, construction of different knowledge graphs, representing everything with mathematical formalism, and using graph transformation algorithms. So this is the outline. We described the system that we developed, and then the methodology that we developed and used, our contributions, evaluation of our system, and acknowledgement. So this is the system that we developed. This is an expert system in the domain of strategic management. It acquires information through a series of diagnostic questions like you see here. For example, this is the knowledge module, and it is asking you questions, and you are giving some Likert scale answers, and then you go to the next question. And at the end, the system makes strategic policy recommendations based on the answers. For now, we are just giving scores for each different strategic management strategy. So for example, the most applicable strategy is this one because it has a weight of 98%, right? So that is the software, and these are different modules of the system. These are different modules within the system. And by the way, you could go to this web link and you can try the software out yourself. It's in the presentation which I uploaded into the system. So it collects data, it collects information, and then based on that information, it triggers suggestions just like a true expert system. So basically, our research scope is analyzing a phenomenal textbook in this domain. We acquire knowledge from there. So we extract the constructs of the elements of strategic management, and then for different actors, agents in expert system development, we develop different grammars, and now we finally also illustrate how this could be applied by developing the system as well. So our hope and goal is that the research that we conduct will help practitioners in industry to firstly to use this system that we developed for learning about strategic management, getting strategic management suggestions, but also the methodology allows for development of expert systems. So if somebody wants to develop expert systems, they could also use these methodologies. So the main motivation was that there are different stages, processes, and team members in expert system development, and each of the project members have different roles, tasks, priorities, capabilities, cognitive preferences, and technical competencies. So these are the different agents that in the system, in a expert system development: the project manager, the domain expert, the business analyst, the system designer, software engineer. So for each one of them, we designed different grammars, different knowledge graphs. The last one is not, after the last one, then there's the final implementation of the system. All right, so this is the grammar for stage 1. And this is the, actually, this is the knowledge graph for stage 1. This is the grammar for stage 2. This is the knowledge graph for stage 2. By the way, this one we draw using YED software, which is an amazing software. If anybody wants to get into graph analytics, this is a wonderful software. And the third stage has this grammar. And for the third stage, we used a commercial software called Vizirule, and we are thankful to the leader of Vizirule for allowing us and use their software, and also supporting us through the research. And once we have those, we also need, of course, when we want to implement as a software, we need a database schema. This is this database schema for stage 4. And we have to have a database, data within the database. And of course, this data is a schematic representation of the rule base. And then another thing that we did was to represent all that we did using mathematical formalism. Okay, so whatever grammar we develop, whatever knowledge graphs we develop, we define them through mathematical formalism. So these are the set of modules, these are the set of suggestions, these are the set of objects, set of attributes and sub-attributes, a set of all possible attributes, sub-attribute values, set of paths, set of logical operators, okay, set of questions, set of start and finish nodes. So we basically represent all these graphs also as through mathematical sets and graphs. Okay, so you can find, by the way, all these details in our supplement document, which is, I think, 25 pages or more, something like that. So the supplement is bigger than the paper itself. So this is the mathematical formalism that we use. And when we have these different knowledge graphs, remember this was the knowledge graph for stage 1, right? This was the knowledge graph for stage 1, and it's basically a mind map, because this is the least technical competent person who's the business analyst. So we want to make something really simple for him. Then the other knowledge graph for stage 2, knowledge graph for stage 2 is a domain objects map. Okay, so that one is a different graph. So what we did is to transform from this one to this one, we have graph transformation algorithm. And we have this graph transformation algorithm from G1 to G2, G2 to G3. We didn't do the back way, the other way around. It would take too much time, space in the paper. But so we also represented these graph transformation algorithms between these different knowledge graphs. And again, we haven't seen anything like this in the literature before. So basically the contributions of our work: the developed expert system strategy advisor cloud, which you can access right now even, is a digital software as a service platform that performs strategic management consulting. And this makes strategic management know-how accessible to small and medium enterprises. Those are the same companies who cannot afford expensive strategic management consulting companies like McKinsey, Boston Consulting. They can't afford that. But here we have a system that collects all the information of a phenomenal, legendary Mercer consulting guru, and that is encapsulated within a software, so any small, medium enterprise can use this. Professors of business, they can use this system in teaching strategic management. And this way, by the way, we're also serving sustainable development goals of United Nations, including quality education and industry innovation and infrastructure. So our project is also serving these two sustainability goals among the sustainable development goals of United Nations by enabling knowledge accessible, making knowledge accessible, and know-how accessible to small, medium enterprises. The second contribution of our research is the integrated multi-stage, multi-agent methodology that is applied for the first time for strategic management domain. And honestly, there was only one paper that we have seen that is even close to our methodology, even within the whole expert system literature. The third contribution of our research is this: for the first time in strategic management literature, visual representations suitable for each stage of the system development lifecycle are identified and formulas specified through visual languages and mathematical notation. These visual representations are in accordance with the goals and tasks of that stage and the attributes of the agents in that stage. So that's our third contribution. Now, coming to our fourth and last major contribution. For the first time, in strategic management expert systems literature, and possibly the larger expert system literature, transitions between the knowledge graphs of the successive stages are formalized as graph transformation algorithms. Again, we haven't seen something like this in other research. You can see all the research that we cited in our work. So finally, we evaluated our system using a framework that was suggested by Nurminen et al. In 2003. This is an old framework, but it's the best one we found. So that's why we basically use this framework to analyze our, the value of our research. So these are the, this is the comparison. Again, since we are short in time, I invite you to please visit our supplement, and then you can just download the supplement. And yeah, we thank all these people who helped our research so far. So many people helped our research so far, and our research was also supported by startup grant funding from United Arab Emirates University, where I am working as a professor, and my colleague Ms. Lakshmi was also a research assistant with us. So if you'd like to learn more about me, please feel free to visit my professional website, which is artecprojects.com. You can also see the drafts of all my final drafts of all my publications. You can find a lot of different resources. And again, my name is Dr. Gürdal Ertek. I am working at UAE University in Al Ain, Abu Dhabi, United Arab Emirates, and these are some of the other emirates within the UAE. If you visit UAE, please feel free to contact me in the future. And this is my background and my research areas. I basically work on data analytics and blockchain, but I have competency in other fields as well. And that's all, end of my presentation. Thank you so much. Hello.
Yes, sir. Thank you for your valuable and great presentation. Okay. Is there any session chair who wants to ask any question to the presenter?
I think maybe. Thank you, Professor, good luck for the presentation. I think not much related to, but just wanted to know, has your system, this expert system, deployed to one of the business so far? Have you applied or deployed this your strategic management?
Yes, it's
To the
deployed on the internet. As you can see, if you go to slide 3, it's also there's a link in the system. So if you go to the web, right now the system is working. So you can, I don't know, 1 minute, please. Heroku app. You know what happens, you know, right? When there's something that may go wrong, it goes wrong at the exact wrong time, right? Strategy advisor, herokuapp.com. 1 minute. It was working yesterday. I tested. 1 minute, please. Let me try the other browser. I mean, it is working basically. I don't know why it's not working. I don't know what went wrong right now, but it was working yesterday. Sorry about that.
It's okay.
Normally it's working. Yesterday I tested it. I will test it right now with one of my colleagues. My colleague, Mr. Riyazuddin Shuvo. He will check it, and he's a professional software developer. Again, I don't know what happened right now, but it's working normally. Okay.
All right. Thanks. Thank you.
Sorry. So you can check out a few days later and try it yourself.
All right. Okay.
Thank you.
Thank you.
Thank you. Kind regards.
Okay. Thank you for doctor for asking the question. Okay. I'd like to invite our next presenter, SM Mizanur Rahman. Sorry for about the wrong pronunciation. And he's presenting on explainable loan approval prediction using extreme gradient boosting and local interpretable model agnostic explanation.
Yeah, thank you. I'm sharing the screen. Can you see the screen?
Yes, sir, we can.
Okay. Thank you. I am SM Mizanur Rahman, along with my co-author, Dr. Ghulam Rabiul Alam, is presenting our study titled Explainable Loan Approval Prediction Using Extreme Gradient Boosting and Local Interpretable Model Agnostic Explanations. Let's go for the introduction and motivation first. Loan approval is a crucial and time-consuming part of a bank, and it takes a lot of time, as well as there are lots of challenges to approve a loan. And the loan is there is a probability to become the loan defaulted. So there should be an automated system to predict the probability of the loan to be defaulted. For this reason, few machine learning techniques is used in academic area, and few results are there. But the nature of the machine learning is black box characteristics. So the business people are not using this, as they are not aware of the process of the decision making, whether the loan is approved or not. As the loan decision is a crucial part of a bank, so the banker is not interested to share a system that are unknown to them, that is black box to them. So we go for our contribution in next slide. Though there are different study is there, and we go for the local interpretable loan local interpretable machine interpretable model agnostic explanation. We will discuss the details in next slide. before that we go for related work. In order to compare and select machine learning algorithms that are most appropriate for learning banks credit data, Tarkson and other looked at real bank credit data and ran many machine learning algorithms on it. Over 80% of prediction made by the algorithm were accurate. Additionally, out of total 23 variables, the most crucial feature that predict whether a client would be default or not. The most crucial feature when they applied to a few chosen machine learning algorithm, their predicted accuracy was compared to the other algorithm that uses all the 23 features. With random forest and AdaBoost, author managed to score more than 80% in identifying the bad loan. Wang and other study primarily compares the result of 5 well-known classifiers used in machine learning for credit scoring. One classifier is superior to another, and each has strengths and as well as weakness. However, the experiment's findings shows that random forest outperforms the competition in terms of precision recall. Precision recall, area under the curve, and accuracy. With random forest, the author managed to score 94.57% accuracy. Our methodology is complementary but distinct in many ways from that used in this discussion. In order to forecast the trustworthiness of a bank credit data, we used a variety of machine learning techniques. Additionally, unlike the studies mentioned here, our study focuses on the interpretability of the proposed model along with classification of the loan status. Let's move on the next slide, description of data. The data employed in the study is based on information from US Small Business Administration. The dataset is consisted of 27 features. The dataset contains around 0.9 million records. In figure 5, the loan status shows that approved loan is represented by 0 and declined loan are represented by 1. It can be clearly seen that the number of approved loan is higher than the declined loan. Figure 3 shows the number of paid or defaulted loan from 1984 to 2010. It is very notable that after 2000, the defaulted loan are increasing, which is a big problematic scenario for the banking industry. Now move to our proposed system model. We initially began by gathering information on bank-related data from numerous sites. Finally, after finalizing the dataset, we started the data pre-processing. Since accurate data appear to be noisy, we have considered a variety of pre-processing techniques to clear the data. We have performed a comprehensive EDA in order to find the relation between the features. Additionally, there were a lot of null values which need to be either handled or deleted. After using our cleaning approach, we applied several models, including decision tree classifier, random forest classifier, XGBoost classifier, logistic regression, and AdaBoost classifier. We employed ROC curve and confusion matrix to evaluate the effectiveness of our model. We also utilize a range of performance metrics such as accuracy, recall, precision, and F1 scores to identify which model tend to be more effective. Finally, based on our study, we export the best fitted model that is most appropriate. Lime, an explainable AI framework, is used to explain the exported model. It can reveal the obscure knowledge that lies behind the model's prediction. Now over to our model specification. First of all, XGBoost. XGBoost is a gradient boosting ensemble machine learning algorithm based on decision trees. It is often used in a multitude of area because to its high efficiency and accuracy. Using the second order derivative as an approximation, XGBoost attempt to lessen the overall model's error. One of XGBoost's most useful feature is the application of parameters that actively change the classifier and improves its accuracy or ease the understanding. Regularization, parallel processing, tree pruning, and the ability to increase learnability are some of XGBoost's best feature. So XGBoost's optimization function aids in the learner's increased learnability. The inclusion of regularization technique like ridge and lasso regression, which lessen models bias, is XGBoost's second most useful feature. Moreover, XGBoost has a high number of hyperparameters that can be tuned up to improve the performance. Now let's move to LIME. LIME is a machine learning interpretability technique that explains the black box model prediction. It is designed to provide local, human understandable explanations of why a particular prediction was made by approximating the behavior of a model in a small, interpretable region around the prediction. It generates dummy version of input data and keeps a local interpretable model to explain the contribution of each feature to the prediction. It is model agnostic and can be used with both text, image, and tabular data. It has been shown to provide accurate and understandable explanation of black box model prediction in a variety of applications. Now our performance evaluation figure shows our findings. After training with various machine learning algorithm, we see that the XGBoost performs the highest. It's 95.58% accuracy. Table 2 represents the precision, recall, and F1 score of the utilized machine learning models. Here it is clearly visible that although random forest decision tree managed to score close to XGBoost, in terms of their precision, recall, and F1 score, XGBoost perform more moderately. Moreover, figure 7 depicts the confusion matrix of each of the utilized machine learning model. Here we can visualize that XGBoost has most true positive and true negative value than any other models. Now the figure represents the ROC curve for the three of the best fitted algorithm. Here we can see that XGBoost has more moderate curve than other two. Now the model's interpretability. Despite the proposed method high precision, it is still important for the classification result to be interpretable. Thus, we have implemented LIME, and figure 10 displays 4 inputs and their prediction and the LIME prediction. Here we mark the here 4 slide is there, and A and D are predicted as 0 and approved loan by our model, and other 2 are predicted as 0. That means declined by our model.
Sorry to interrupt you, sir, but you have last 2 minutes.
Okay. Okay. Finally, the conclusion. This article proposed a comprehensive machine learning based architectural framework for determining if a loan should be authorized or not. 5 different techniques are used, and each algorithm attain accuracy rate 86 to 95%. The LIME is our proposed solution provide the highest result. These are the references, and that's all from us. Thank you.
Okay, thank you very much for a very valuable and great presentation, sir. Do we have any question for the presenter, sir? Bansal, sir?
May I ask a question, please?
Yes, sir, you can.
If I may ask, which libraries did you use? Which which technologies, which library did you use?
Sorry, can you please repeat?
Yes, thank you so much for the great presentation. My question is, which software or software libraries did you use in your analysis?
Python.
And which Python libraries?
Hello.
Hello, which Python
Yeah.
libraries
The
did you use?
TensorFlow libraries we have used to
What's that?
analyze the TensorFlow.
TensorFlow. And for explainable AI?
And that's also the TensorFlow model. The Lime is also in our TensorFlow.
Okay, thank you so much.
Thank you very much.
Okay, thank you, dear presenter. Okay, now I would like to invite our next presenter. Our next presenter is Rita M. Umuthoni, and she's presenting on integrating analogy PIR sensor telemetry with TinyML interface for on-the-edge classification of moving objects. Dear presenter, you may please start your presentation.
Yes, can you see my screen?
Yes, ma'am, we can see your screen.
Hello, everyone. My name is Umuthoni Maririta. I'm a master's student from University of Rwanda in African Center of Excellence in Internet of Things, specializing in embedded computing system. I'm going to present our paper entitled Integrating Analog PIR Sensor Telemetry with TinyML Inference for On-Edge Classification of Moving Object. From the work that was done by me and Marvin Ogole, Dr. Jimin Senga, and Prof. Damien Hanagifo. This is what you are going to see in this presentation. Introduction, aims of the study, related work, proposed solution, system architecture, and conclusion and future work. Identification of moving objects play important role in real-time application, especially in monitoring, especially in surrounding environment, in security, in management of social distancing, home intrusion surveillance, in proximity detection in dangerous. So moving objects we are targeting are humans, animals, and brown vegetation. The techniques of the object detection mostly used are image processing, which intend to be the hot topic for object detection, but it has some limitation, which include that it requires high computational cost. It has it needs high quality image, and it has low. It tends to have low resolution due to the absence of light, and it requires high bandwidth. It even like the privacy. So to overcome this limitation, there is some of the systems use digital PIR sensing, which tends to overcome image processing limitations, but also fail to address the problem of moving object identification. That is why there's also analog PIR sensing, which use voltage values as presented in sinusoidal waves that can be extracted for the statistical machine learning for more accurate object detection. The problem statement: despite moving object detection using computer vision become trending topic, there's still different challenges. Some of them are data which contain noise. This means that when you are using a camera, you just took everything in the environment. So, and when there is the absence of light, you can have the low resolution camera. There's also the problem of security. When they are taking your images, it means that there is a privacy intrusion. So there's also the problem of money. So those high computation costs, the expensive devices tends to make the cost a problem. So here are the challenges that are most available when you tend to use to use your model on the cloud. So these challenges are latency and bandwidth, which tend to be high. Real-time execution, when you are running your model to the cloud, is a problem. And power consumption, it requires and need high power consumption, which tends to reduce the battery life of the system, the cost. So our proposed approach is to take our machine learning model and to put it on the cloud, where we'll be using edge inference. So edge AI solved those challenges, the one I mentioned in previous slide, by moving the AI model to the data source, including machine learning on architecture, and can be implemented on low energy or memory system integrated with the chip. The one we are proposing here is Arduino Nano BLE Sense, as you see it here in the image as our target TinyML device. So the aims or objective of the project is to present the solution that demonstrate how IoT can be integrated with machine learning on the edge. We reviewed the different existing solutions, and then we designed and developed a prototype that can detect objects in proximity to collect parallel data needed to train AI model, and then to propose the TinyML model inference accuracy by CNN learning on device. This is some papers. So many papers we read on literature review. So one of them is optical camera complement to PLR sensor for intrusion detection and classification in outdoor environment. Here they used a camera and a PLR sensor that can detect the movement, and then a camera to detect the object and identify them. And the other ones, most of them are camera based. So the gap which we found in these solutions are privacy intrusions, low light conditions in case of camera, and even the expensive hardware setups. Like if you make setup of PLR sensor and the camera, it's like you are doubling the work. So our proposed solutions here, we are proposing intelligent device that can detect object in motion using non-intrusion, non-contact, and chip sensor, which is analog PR. The architecture is as follows. You will collect the data, and then after we get the data, we process them. After processing them, we visualize them to check if it can be differentiated using how originally they look like, but like using skewness, minimum, maximum. And then we use the deep neural network. we got output of different classes, human, animal, and vegetations and anomalies. And here there's data collection campaigns. On the left side, there is a device we used to collect data, which made of analog power sensor as the targeted device, and we used Arduino and SD card and SD card to save the data and the clock for timestamp. So we collected data from different moving objects. Since we found out there is no available data set, we tried to contact the people who did the work related to ours, but they told us that the project were private, so they cannot share the data with us. That is why we decided to do data collection. So on this graph is how data looks like after we collected them, like without any processing. And then this one which showed the low data person SAT7 is when we started processing and trying to convert the data we got into time series. So here there is how we made time interval with their corresponding observations. We have two classes, time intervals, and they are not the total number of observations which come up of. So here is the accuracy we got from each observation corresponding time interval. So we got that the one which has the highest accuracy is 1 second observations, which has where we got 1,287. And we compared different parameters, performance of digital signal processing. Here, when we try to build our model using only low values without doing any computation, we've got 24.8 accuracy with loss of 1.38. And then we tried to change and try to flatten, where we can take the low values we got from collecting data, from data collection, and then do some computations like averages, mean, and then we got 79.8 with loss of 0.7. And also there's other technique of spectral analysis, where they analyze the frequencies, which tends to be the best techniques for our data, which was in sinusoidal mode or sinusoidal waves, and it tends to give us 8.8% with loss of 0.7. So here there's our neural network architecture using spectral analysis, because deep neural network already do the feature extraction. When we perform the feature extraction, got the input layer of 11 features, and then we computed with density of 48 neurons and density of 20 neurons, which tends to output 4 classes of our output. And then here are the results. On the
Sorry
training
to interrupt you,
accuracy.
but you have
On
last 2
training.
minutes. Ma'am.
Okay, this is the result for training and testing accuracy. Here is the result when we try to optimize and quantize our model from cloud to the edge. So it performed very well. It was classifying our moving object. Here, for example, for the animal. So our conclusion, the the device was developed that can be used in proximity sensing, monitoring house securities, and we end up with time series data set which can be public. And also we end up having a solution that can have our privacy at and also take consider of the price too. So for the future work, the accuracy may be improved over time using reinforcement learning, and also we want to include different animals since for the ones we detected are for only dogs and goats. Thank you for your attention. That is the end of our presentation.
Okay, thank you for your great presentation. Is there any question for the presenter, sir? And if any presenter want to ask any question to the current author?
I think yes, I have one question. You design a system using PIR sensor to detect movement of objects. Did you devise with the AI, with the algorithm? Is it can define the kind of objects? I mean, you detected this animal, this human, this just like something obstacle or objects. Is your device can define the object detected?
Okay, thank you. Let me show it here. So we have since we collected our own data, we have the object detected. Like in animals, it can be able to detect very well goats and dogs, because we combine that class because it tends to have the same features. And also we have humans, and we have another class called object, just in the sense in case there's nothing is moving. And then when you try to detect something like maybe a cow, it can be listed as anomalies. So I think I answered your question. Like as you see here, that is how you can see the classification.
Okay. Yes. Thank you. Just opinion because one of the application of the system is for the security, because I got many experience. Sometimes the security object detected is not humans, so like just something fall, then the sensing detected is we need to differentiate this human that as a threat for the our house or our office something. This animal just passing through. This is a car or motorbike. Anyway, thank you for the answer. I think that's all. Thank you.
Okay, thank you.
Thank you, Dr. Kadir, for the question. And thank you, dear presenter, for your valuable presentation. Now, I would like to request our next presenter. Okay, so our next presenter is Hazar Noshid, and she's presenting on a mining fleet management system in real-time state of art. Dear presenter, you may please start your presentation.
Good evening. Can you hear me, please?
Ma'am, your voice is not clear audible.
Can you hear me, please?
Yes, ma'am. Now we can hear you.
So, I am trying to. You can see the presentation.
Yes, ma'am, we can see. Please make it full screen and start your presentation.
Okay. Good evening, honorable judges and dear participants. My name is Hazab Naashir. I'm from Morocco. I'm a PhD student at National High School of Electricity and Mechanics. First, I want to thank scientific and organization committees for giving us the opportunity to present our research work. My talk today is entitled Fleet Management System in Real-Time State of Art. My presentation is outlined as follows. The first part consists on a general presentation of the subject and characteristics of fleet management problems and its resolution approaches. Throughout the second part, we'll discuss distribution, algorithm limitation, and also systems architectures models. And finally, conclusion and perspective. So for the introduction, mining is generally considered as a basic industry. It's characterized by difficult and dangerous working conditions. Mining projects, and especially open-pit mines, are a capital-intensive enterprise with high operation costs. Approximately 50% of the operation costs of open-pit mines and much as 60% in large open-pit mines are spent on transportation and material handling. Of all the material handling operations in open-pit mine, it has the highest operation costs. Then comes fleet management system to optimize the costs of mining production. So, first of all, I want to present what is the characteristic of fleet management problems in real time and how can we solve these problems. Based on many studies, we can classify 4 groups of characteristic of fleet management problems in real time. Namely, state observation, forecasting anticipations, evaluation, and decision. For example, for state observation, we can find 3 sub-characteristics, namely time dimensions, which is necessary that the dispatcher knows the geographical position of each vehicle at all the time. Next one, updated information, then the feedback of the fleet must be in real time in order to solve problems as quickly as possible. And sizing of the fleet, the size of the fleet must be relative to any change in the identified need. So, the fleet management fleet management system is a term used to refer to a wide range of weapons for various applications in transportation, broadcasting, and coordination. It includes the organization, management, and control of fleet activities, as indicated by accessible vehicle resources and application requirements. The FMS, the Fleet Management System, aims to reduce risks, improve the quality of administration, and increase the operational efficiency of the fleet while maintaining low costs. In our case, in mining context, a fleet management system, as the figure shows, is operation in mining operation is a decision-making system that makes real-time decision for handling material in open pit mines. The FMS obtained the required information about the status of the operation from the databases and make decision accordingly. The decisions are then implemented in the operation, and the FMS is recalled whenever a new decision is required. In fleet management system in open pit mine, a track allocation model includes 2 types of allocation: a fixed allocation and dynamic allocation. A fixed allocation or a fixed distribution. This approach puts a number of tracks on a fixed transport route where they will stay until the end of the shift. This route won't be changed until a shovel malfunction or a signification event take place. The fixed allocation technique is a static method. The dynamic distribution or dynamic allocation is a dynamic track allocation where a number of available tracks in fleet are assigned to a specific work shovel at the beginning of the shift. Wherever this track inside of being at the service of a single shovel or a road during the shift, they will receive a new assignment for the dispatching system each time after loading and uploading the hopper at the hopper. It has been demonstrated that the majority of approach to solve track dispatching in OpenPitch Mine can be classified in two categories: simple single-step and multi-step methods. In a single-step approach, in the one-step approach, tracks are allocated without regard to many constraints or a production target, usually following a rule of thumb. When the one-step approach is used, tracks are allocated to shovels and the basics of available experience, without taking into account specific needs and or operations conditions. In fact, this is a heuristic approach which is purely empirical in nature. The second approach, which is a multi-stage approach, the multi-stage approach has been shown to superior to a single-stage approach because it takes into consideration the production targets. The multi-stage system generally divide the dispatching problem into two or three sub-problems, including setting the production target in a higher stage and allocation track for shovels in a lower stage with an objective of achieving the production target set by the higher stage. So in this approach, multi-stage approach, involve resolving three sub-problems, which is short path, optimization of production and allocation of track, and real-time distribution, with the result of each stage being utilized as input of the subsequent sub-problem. There is a three related sub-problem, which I said says short path, optimization of production and allocation of tracks, and real-time distribution. The development of fleet management system for use in the surface mine has attracted a lot of research attentions. But the currently chosen algorithm and model still have some limitations. For example, the proposed fleet management system in literatures do not achieve both term and long-term objectives. Mass models are dynamistics, assume a constant average grade for each phase, or do not cover the entire life of the mines. The proposed model should have realistic as possible by taking into account the heterogeneity of the track and the full modeling of an open pit mines operations. So, to propose a new fleet management system, you have to understand first what is architecture systems and what is its types. According to Henner and Kammer, architecture is a description of a composition and structure of piloting systems. And according to Turnstall, piloting architectures can be composed of biological or artificial being with a certain intelligence and communications for interaction capacities. So, from these definitions, we can conclude that management architecture include all the entities of systems and relationship between them. There are three types of architectures: component-based architectures, services-oriented architectures, and agent-based architectures. This is example for each type. And we have in this table we can see a comparison between the three architectures has been carried out on the following criteria, which is autonomy, cooperation, reclusivity, direct integration. We can see that the multi-agent architectures shown good in this criteria. So, in this presentation, we have presented part of a state of art that we have carried out in our research, and consequently, we have proposed a multi-agent architecture for fleet management system based on ESA 95 standard and taking into account the real constraints of the open piece mines, and we also carried out mathematical models for the dispatching part. And now we're working on a simulation of this architecture of a fleet management system, intelligent fleet management system. So thank you for your attention.
Okay, thank you, ma'am, for your great presentation. Sir, do we have any question for presenter?
Yes, we open to other audience.
Okay.
Or,
From audience, any question if you have, can ask.
okay, no, I just a simple question. Thank you, Ms. Hajar, for the presentation. In order to make it a real time, do you use something, what kind of sensor or system that you can manage as a real time for the plate management system?
So with our team, we have proposed intelligent fleet management system architectures. We use sensors which is implemented in the shovels and a track. We can help us to get information on real time and get to process get processing with this information to get information to dispatching, get a good optimized dispatching of truck and shovel.
So how you, so far that you applied in the real case or just simulation so far?
I don't understand.
So you visited the truck, the dump truck just now as I saw you your presentation.
Yeah.
Did you apply, you install something on the dump truck or just you do some simulation? Did you apply? No. Yeah.
Yes, I understand now. So I working on the simulation with InnoLogic.
Yeah.
Because it's difficult. It's difficult to implement our solution in real with the real data because the security, data security.
I see. All right. Oh yeah. So I get it. Thank you for the answer.
Thank you for organization.
Okay, thank you, ma'am, for the presentation, and thank you, sir, for your question. Okay, now I would like to invite our next presenter. Our next presenter is Leonor Portugal da Fonseca, and she's presenting on user interface design and evolution of the Impact Rally rehabilitation platform.
Good afternoon. Do you see my screen?
Yes, ma'am, we can see your screen.
Okay, thank you. Good afternoon. I'm Leonor. I'm a research in Coimbra, University of Coimbra in Portugal, and I'm going to present our work on the user interface design and evaluation of the Impact telerehabilitation platform. I will start by the context, moving for the evaluation, the results, and finishing with the future work. Physical rehabilitation controls and improves several health conditions, which can be musculoskeletal, neurological, and cardiorespiratory. Musculoskeletal conditions affect 1.7 billion people worldwide and is the most prevalent condition. Physical rehabilitation helps to treat and alleviate some symptoms, but for this to be a good process, it must be a continuous process. This requires a high human resources and high financial costs. Alongside with longevity, sedentarism, and the high strain on health services, it became an unsustainable health system. Telerehabilitation came to mitigate this problem. Telerehabilitation sessions take place outside the health units, like clinics, hospitals, and they optimize processes and avoid unnecessary travels from the people undergoing rehabilitation. It helps to reduce waiting lists, and it takes physiotherapy care to people in remote and unprivileged areas. The Impact System project aims to create a low-cost remote rehabilitation platform with a camera that allows for a holistic visual perception of the user's movements without any user of markers. We use a human-centered design approach, and we built two interfaces, one for the person undergoing rehabilitation, we called it PER, and one for the rehabilitation professional, we called it RP. The RP sets a series of exercises into the session that is designed for a specific PER. The PER logs into their account, they choose their session, the day of the session, and they start the exercises. The system collects all the data associated with movement, and then later on, the RP analyzes all the movements that were from that session. This is our physical station. On the top, we have a screen to display the rehabilitation sessions and exercises, and it provides instructions and real-time feedback. Above, we have a box with a mini PC, a microphone, a speaker, and a camera to track the PER's movement. Here you can see the interface of the RP user. You can see that there are a lot of data collected and they are grouped into specific categories. And for the evaluation, our goal was to assess the usability of the user's interface, the point of view of the participants on the usefulness of the functionalities, and the odds of them recommending the system to other people. On the usability evaluation, we ask participants to go through a set of tasks that would be the normal tasks they would go through on a normal day using the app. We ask them, for example, to change the settings to choose the preferable background or to leave a message to the RP. On the RP tasks, we ask them to check the performance of a specific PER or to create a general session plan. During the tests, we record the duration, the number of errors, and the task completion. We also asked an extra question about the usability answer on an 8-point scale. For the post-task questionnaire, we also use an 8-point scale. For the PERS, we use the system usability scale, the SUS. And for the RP, we use the computer system usability questionnaire, the XUQ. During the evaluation, we were 2 members of the team, one as an observer to mainly take notes and see what's going on, and one facilitator to guide the participants through all the tests. The participants were 5 PERS with ages between 25 and 65 years old, and 5 RPs with ages between 18 and 25 years old, and 2 to 5 years of experience. As a result of the PERS interface, we can see that the task 3 was the one that took the most, and the 3 first tasks were the ones with the highest number of errors. On the results of the SUS on the PERS interface, we got an overall of 72 score, which means that we have an overall system usability acceptable. Despite of the results, we identified a series of corrections needed to implement. We will identify here the most important ones. We understand the importance of adding a send button anytime a per wants to send RP a message. We want to allow users to play music while using the application. We need to develop various feedback interactions, and we need to develop application responsiveness. On the RP's interface, we can see that task 2 is the one that took the longest, and in comparing to the PERS interface, the number of errors were significantly low on the RP's interface results. On the XUX results, this table shows all the data collected, the scores they presented to each task. And despite of the poor result on the task 7, that was regarding the information quality, our overall score was still positive. Regarding the corrections, we understand the importance of displaying the correct name of the pain and fatigue scale, that is Ivan Borg. Display the medical history and diagnosis of the users. Set a range of execution time for the sessions, and demonstrate the videos of the exercises so the user can understand what is supposed to be done and do it correctly. As a general correction of all the interface, we understand the importance of displaying error and confirmation messages. For the net promoter score, that was the question about the odds of promoting or sending this system for other people. We got on the PERS side a promoter score, it was a total of 80, and on the RP side a total of 60, that is a passive. As for the future work, we want to introduce gamification elements to the system so we can promote motivation, adherence, and continued use. We want to study the interactions between the PERS and the RPs so we can replicate these interactions in the application. We perform already an heuristic evaluation on the PERS interface, so we identified all errors and we are now in the process of correcting them. And we want to continue to develop the application and hopefully get a good final result. Thank you.
Okay, thank you, ma'am, for your great presentation.
Thank you.
Okay, sir, do we have any question to the presenter?
Other presenter have question maybe? Just simple. Thank you for the presentation. So far, how many participant or you do a rehabilitation for the human people? So far, how many case that you do on the testing on the try? So how is the result and the accuracy?
We did 5 tests on the PERS side and 5 tests on the RP side. It was a low number of participants because it was still in the early stages of the process. And now after all these tests and all these corrections, we want to do more tests with a higher number. It was a pilot study.
So far for the 5 testing, how is the result? Is it good result or the how the result you got so far?
Sorry, I didn't understand.
Oh, you do so far is you do 5 testings.
Yes.
Is it achieve your targets so far?
We did the tests with our target audience. Yes.
Oh, I mean, yeah, because different different. I mean, you do rehabilitation for the. You need to take samples, many kind of the background or the human, or then you get various of the data or samples. Then you can improve your system, your user interface. Just a suggestion, something like that, because one of my friends they need to get the sample or test in various of object or background of human to do the test. So, I don't know the so far the 5 case you do, is it the same background or different kind of background code? It's okay. It's okay. I just curious about that. Okay.
Sorry, I'm someone who's working with Leonora. I'm going to answer this one. So there's no data yet on the in this particular paper. We are not reporting on the data collected from the machine learning model. This is only about the user interface design. As with regards to the results of the user interface design, they were in the tables which were presented previously. We were looking at the usefulness, the utility, and we applied the XUS and the SUS questionnaire.
Yeah.
The results were quite positive.
Okay, I get you. You focus on the UI user interface at the front end. Okay, thank you for the answer.
Yes, you're welcome. Thank you very much.
Question. Okay, now we have completed all the presentation for this session, and I will also I sincerely thank our authors for their excellent presentation and great contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough to all the participants. And we, on behalf of whole team, thank you for your support during this version and previous version of this conference. And we'll be happy to have you all in the next version of this conference in 2024. For the moreover, all the participants will be getting their digital certificates through email within 2 working days. And for all the papers have been already forwarded to the Springer. So, and the publication will be live within 5 to 6 months. So kindly cooperate with team ICICT 2023. And I also want to thank our session chair for chairing the session. And so there is one token of appreciation to the chair on behalf of 2023 and Global Knowledge Research Foundation. Just a second, sir. Yes.
Yes, thank you. Thank you. Sorry, I got interrupt just now. Yeah, thank you to the ICT 2023 to invite me as one of the session chair for this session, room C. Again, thank you very much. See you next time. Thank you.
Thank you, sir. Thank you for your valuable presence over here. And I also want to thank our session chair, Jagdish C. Ansal. I think so. Is facing technical issue, I think, during the session. No worries. Okay. So in the end, I just want to request you all to turn on your camera so we can capture some good glimpse of this virtual conference and make this conference more memorable. I request all the participants, please turn on your camera. Thank you. And thank you, sir, once again. Okay. Stay safe, everyone, and take care.
Okay.
Bye-bye.
Thank you. Bye bye.